Welcome to the Not Old Better Show, the show covering all things health, wellness, culture, and more. The show for all of us who aren't old, we're better. Each week, we'll interview superstars, experts, and ordinary people doing extraordinary things, all related to this wonderful experience of getting better, not older. Now, here's your host, the award-winning Paul Vogelzang.
Welcome to the Not Old Better Show on radio and podcast, the go-to broadcast for aging adults and their families, where we delve into the marvels of modern medicine, the persistence of science, and the stories that shape our understanding of health and wellness. I'm Paul Vogelzang, and today's show is brought to you by GoldCo, Protect Your Retirement Savings, and CrunchLabs, Think Like an Engineer. And we are coming to you with an episode that promises to be as enlightening as it is inspiring. Today, we're venturing into the realm of scientific breakthroughs that have the potential to redefine medicine as we know it. We'll be discussing a riveting new book titled The Medical Revolution of Messenger RNA with none other than its author, the esteemed science journalist Fabrice Delaye. In his work, Delaye chronicles a journey of discovery and innovation that changed the course of medical history. Most of us became familiar with the term mRNA during the COVID-19 pandemic, but the story behind this medical marvel spans far beyond recent events. It's a tale woven through decades, featuring unsung heroes, persistent researchers, and a series of breakthroughs that almost never were. As Fabrice Delaye reveals to us today, mRNA technology, once on the periphery of scientific research, now shows extraordinary promise for treating a myriad of conditions from cancer to rare genetic disorders. It's a narrative that not only captures the essence of scientific endeavor, but also speaks volumes about the human spirit's resilience. So, whether you're a lifelong learner, a professional in the field of healthcare, or someone simply curious about the future of medicine, just like so many of us in our Not Old Better Show audience, this episode is for you. Join us as we explore the untold story of mRNA with our guest today, Fabrice Delaye. mRNA has this transformative potential, and the lessons it teaches us all about the value of perseverance, hope, and the quest for knowledge will be fascinating, so stay tuned. We're about to embark on a journey through the past, present, and the thrilling possibilities of tomorrow with Fabrice Delaye. Let's begin. Fabrice Delaye, welcome to the program.
Thank you. Thank you for having me on your show.
Well, thank you for joining us today. I get a chance in my work to do a lot of reading, and I get a chance to do a lot of reading on a favorite subject of mine, and that's science. You have written this wonderful new book that I would just say, from the title of it, it didn't exactly grab me right out of the gate, and I'm sorry for just admitting that right up front to you, but I will say to my audience, trust this interview, trust Fabrice Delaye. The book is amazing, the title of which is The Medical Revolution of Messenger RNA. It is a bit sciencey of a title and maybe a bit technical, and I want to get into that because it's got this fantastic, almost thriller component to it, and we'll talk all about this. But I hope you're well. Congratulations on the book, and let's just jump right in. How did the subject of this messenger RNA first get your attention? Because the prologue of the book, again, the title lends itself to being very sciencey, but the prologue of the book has a title to it called 1960 to 1990, The Beatles Years of mRNA. So I love that, and again, I love the book. So let's just jump right in, Fabrice Delaye.
Yeah, so it all started with the pandemic, naturally, because, as you know, the two vaccines that finished the line, first on the line in the sort of competition that was organized by Operation Warp Speed at the time, were both based on this new technology, messenger RNA. So I myself became sort of knowing about that it was in April 2020 when those candidates, there was 8 candidates that were funded by the Warp Speed operation in the U.S. and 4 different technologies, 2 of them messenger RNA, a technology that has never been authorized. It has been tested before, but never authorized for a vaccine. So I was following that mostly because Moderna, one of the 2 developers of this vaccine, was collaborating with a Swiss company. I'm from Switzerland, and the company there is Lonza, and Lonza is a manufacturer, and they were going to manufacture the mRNA vaccine in case of success for Europe at the time. And so that's how it started. And then I followed with no real preference, I must say. And when the mRNA vaccine finished first in this sort of competition with months of advance compared to other technology, it was in December 2020, then the FDA issued an emergency authorization based on the clinical trial that has just been achieved. Everybody was like, yeah, but how is it possible? How could they have developed a vaccine within 10 months? It seems, with a new technology, it seems something almost impossible. And I think the question was legitimate. And so I started sort of digging into what could have been the scientific and technological roots of this development. And then I discovered that there was like a 60-year story that started. That's why it started in the Beatles years in the 60s, with the discovery of the messenger RNA as a very important molecule in our biology. And then I discovered that the development of this technology has been quite dramatic because everybody knew about DNA. It was all about DNA, and if you control DNA, you can do so many things, and etc. And mRNA was always sort of the little brother, the hidden little brother that was not trusted by pharmaceutical company, by many scientists, and only a group of outsiders somehow. I mean, they were a professor in university, and they were researcher in pharma company, but still they were a little bit outsiders because they were working on this very unstable, seems impossible to obtain anything with it. And I discovered quite dramatic story because this researcher's personal story was quite extraordinary and unusual in many ways. And they were outsiders. And so I've decided, I basically tried to find the story to start with, and because I didn't find it, I decided to reconstitute it and to write first a series of articles, and then the series of articles were pretty successful, and then I was contacted by a publisher to transform it into a book.
Well, again, we're glad you did, and congratulations. You talk about the dramatic, of course, you talk about this drama, and certainly there was a lot of drama around the vaccines, the creation of the vaccine worldwide. We had just a pandemic that had all of us watching closely, looking for hope, and miraculously, in terms of what the media was reporting, it took about 327 days, about 10 months, to come up with this COVID-19. But that's not the complete story, as you suggest. And so maybe take us a little bit more behind the scenes and tell us from kind of a layperson's perspective, what is messenger RNA? How does that work, and how did it lend itself to this COVID-19 vaccine? Yeah.
So you have to go back in time. In the 50s, there was 2 absolutely major discoveries that are going to transform the biology and pharmaceutical and medical research. There is, on the one hand, Fred Sanger in the UK, who is discovering that proteins are the building block of life. They are in our cells. Proteins are doing basically, there's hundreds of thousands of different types, and they are doing basically everything. They are an antibody is a protein, insulin is a protein, erythropoietin that is carrying the oxygen in the blood is a protein. There's proteins that are receptors. There's proteins that are transmitters of information. All kind of proteins. And it discovered that this protein have a specific. Each of them is characterized by a specific sequence, an order of its chemical components. These chemical components are called amino acids. But I don't want to dig too much into science, but it's important to understand that it's a sequence. There's an order that will give this protein its specificity. In parallel, other researchers, Watson and Crick, made the discovery of the DNA. They discovered that in the 37 trillion of cells that makes a human body, there's one common element that you find in every cell. That is this DNA. This is the piece of information. This is the code of life. This is where the information that is that is at the roots of everything that happens in our body is stored. And it's also organized into a sequence. And so the question was, how do you go from the sequence that is in this DNA, which is like, if you take a comparison with a computer, that would be the hard drive, the memory, where you have everything ready to be used, but you don't want to use everything at the time. A protein would do, the protein at the other side, if you want, is the software that will execute thing. It will be the browser of your web for searching the internet. It would be a widget on the site. It would be the thing that will play the video. I mean, all kind of function. But imagine protein is a little bit the same. They are doing all kind of function.
And this is really where the sequencing comes in, right?
Yeah, and so exactly, yeah. And the order of information is producing a certain result. And so the question was, how do you go from A, the DNA, to C, the protein doing things? And so what was the B in between, if you want? And so they discovered in the 60s, three French researchers at Institut Pasteur at the time, working with colleagues worldwide, naturally, they discovered this molecule, messenger RNA, which basically take a little piece of information from the DNA, copy it, but not all the DNA. It just take like some genes information, copy it, send it into the cell, into a little factory that are called ribosome, and it's like a blueprint, it's like a plan of a protein, and then this little factory will produce the protein, and the produce will then go or in the cell or out of the cell, depending of its function. So it was very important to discover that there was this in-between piece of information. But the problem was that, so the years that came after, there was a lot of work of how it is organized, how does it change, how does it travel from the nucleus, from the DNA to the little factory. I mean, they have to characterize the whole machinery. But the problem was that mRNA, which is a universal mechanism, all form of life is using mRNA, including virus. The COVID-19 virus is an mRNA virus or RNA virus, and so they were characterizing it, but this molecule is very unstable. The mRNA in biology is not there to last. The DNA, we have found intact fragment of DNA into bones, into the pergelic soil, the frozen soil of Siberia, where we can find intact DNA of mammoth, very stable. On the contrary, the mRNA disappears within minutes. It does its job, delivers its information, its blueprint, and it's gone. The biology gets rid of it. So how do you work with such an unstable particle was a big question, because the question that came after in the 70s is that if you have this piece of information, be it the gene or be it the mRNA, you can produce protein at will. You produce the blueprint of whatever you want as a protein. You inject it into the cell. You deliver it into the cell, and it will do the same job. It will produce the protein that you need. And many diseases are dysfunction of proteins. So you lack certain proteins. So, for example, in diabetes, you are lacking insulin. That's why you have to inject it with a needle. In other, you have too much of this protein. In other, you have this protein that shouldn't be there, like in cancer. There is proteins that are abnormal and that can be targeted to create cancer. So the idea was to use this information technology to deliver this blueprint at will and then create the type of protein you want. But it's very, very challenging to do. And so at the end of the 80s, started the technological development of messenger RNA as a platform, if you want, to deliver information to make this protein. But biology is not easy, and at the same time, people say, well, we have DNA. We know how to, modify the DNA with genetic engineering. So, because if we control the DNA, which is like the king, if you want, on that biological chessboard, if we control the DNA, why would we care about this mRNA? It's just a servant. It's just a piece of information that anyway comes from the DNA. So everybody was working on the DNA, and only a few researchers stick with mRNA, and at the end they prove right, because when the pandemic strike, we have all, if you want, the different elements they were on the shelf. Fundamental science has brought all the elements that was needed to make this mRNA, to synthesize this mRNA for a vaccine, to transport it within the body, to be sure it is safe and it's not going to have perturbative effect, or et cetera. And so that's why it takes so long.
Yeah, it's just such a fascinating component of science, because, as you say, this messenger, the blueprint, it really becomes a set of instructions, as I understand it, and those instructions actually teach. And in this case, the instructions taught the immune system, and it recognized this virus in COVID-19, and that's really what led to the vaccine. Yeah, just an amazing story. But it's If you go back to, you can produce any kind of protein you want with mRNA. You just program the plan of the sequence of the protein you want, and the cell will do the job naturally. So you can produce proteins that, like I give the example of insulin, that are lacking in our body, but you can also produce proteins that will prime the immune system. And normally when you develop a vaccine, most vaccines, there's a few exceptions, but most vaccines, they are based on a technology that is pretty old now, which is basically you cultivate the virus, you multiply it in enormous quantity, and then you make it benign. You irradiate, most of the time it's through radiation, that would destroy it a little bit. Then it is not dangerous, but it still has its shape that the immune system will recognize. But what if, instead of producing an entire virus, when you are in a pandemic situation, you don't want to have more virus. If you produce them in a bioreactor and the bioreactor is leaking, well, you got a problem. So instead of producing the entire virus, why do not produce only a protein of this virus that is very, very specific? It is the one it's called the spike protein in this case. This is the protein that binds the virus to the cell for it to
infect the cell. So it's a key protein of the virus. So you just produce this protein and not the whole virus. Then he will not reproduce. It will be just just this protein, and then you make the plan of this protein with an mRNA. You inject the mRNA in the cell. The cell produces the protein. The immune system say, "Oh, this is not to do here. This is foreign," and so when the immune system will see the real virus, it will simply recognize this protein and say, "This has nothing to do there," and it will destroy it. That's how it works.
Hey everyone, it's Paul. Just a quick break before getting back to our science interview series with Fabrice Delaye. I have a question for you about your retirement funds. Have you crossed the benchmark of saving $50,000 for retirement? If so, give yourself a pat on the back. We are navigating unpredictable times, which makes it paramount to diversify and secure your retirement savings. I have taken the action by investing in precious metals like gold and silver. My experience, absolutely seamless, thanks to our sponsor today, GoldCo. Their top-tier service and the simplicity of the entire process left me truly impressed. They have some amazing credentials. Their credibility, undeniable. They have successfully aided thousands of investors with an astounding $2.5 billion placed in gold and silver. GoldCo stands tall with an A-plus rating from the Better Business Bureau. Their reputation further shines with over 5,000 five-star reviews. Their excellence is evident as a 7-time Inc. 5000 winner. So here's the golden opportunity for our dedicated Not Old Better Show listeners while supplies last. GoldCo is offering up to $10,000 in bonus silver. Curious? Dive in and diversify your savings. Visit goldco.com/Paul for these wonderful savings right now. Remember, that's goldco.com/Paul. So secure a bright and diverse future with gold and silver. Let GoldCo be your trusted companion in this journey. Remember, while supplies last, GoldCo is offering up to $10,000 in bonus silver. Check it out now. Hey, it's Paul. Before we get back to today's science interview series guest, Fabrice Delaye, I've got an exciting shout out to our fantastic sponsor, CrunchLabs. Imagine a monthly journey where learning becomes an adventure. That's CrunchLabs. CrunchLabs is a unique build box experience curated by the one and only Mark Rober, a former NASA engineer and Apple employee, and then he became a YouTube sensation. Let me share my own aha moment with you about CrunchLabs. Picture the joy of building, the thrill of learning, and the pure delight of discovery all in one box. That's the build box that you get. And here's the fun twist. Think of it as the perfect holiday gift for your grandkids, complete with classic spider pranks on grandma. It's really great. So this holiday season, level up your gift-giving game by introducing CrunchLabs to the young ones in your life. Certainly the ones young at heart in your life. Let's make this holiday season unforgettable with the wonders of STEM. Here's what sets CrunchLabs apart. Mark Rober, the founder and CEO, has just this infectious passion for sparking excitement about science and engineering. He does this with every build box that you get. So you're not just building, you're experiencing those big aha moments. From learning new STEM principles to a whopping 80% of kids gaining a new passion for STEM and engineering, CrunchLabs is a game changer. Plus, it promotes healthy screen time. It builds interesting toys. It gives you some one-on-one time with those young ones in your life. And it even offers a chance to win a golden ticket to visit the CrunchLabs Studios. Amazing, just amazing stuff. And did I mention sustainability? Always important to our Not Old Better Show audience. CrunchLabs is committed to being eco-friendly from the box to the compostable bags inside. Ready to create lasting memories? Head over to and unwrap a world where kids learn and have a blast thinking like engineers with CrunchLabs. So this holiday season, gift the joy of learning with CrunchLabs. Let aha moments and hands-on learning become the foundation for a lifetime of STEM understanding. And who knows, maybe a spider prank or two. You'll love this if you watch those YouTube videos. So visit crunchlabs.com/NOB and make this holiday season truly magical. Now let's get back to our science interview series with guest Fabrice Delaye. Our guest today is Fabrice Delaye. Fabrice Delaye is the author of the new book, The Medical Revolution of Messenger RNA. It is an amazing book. Fabrice Delaye is a science and technology journalist based in Switzerland. I referred to the book earlier as a thriller. That's not just my word. The book is getting great reviews for people other than just me. As a matter of fact, Seth Berkley, a physician, says the 327 days it took to make the mRNA COVID-19 vaccines changed the world of science. Fabrice Delaye's book tells the fascinating inside story of the many years of scientific endeavor it took to make it happen. Again, just a wonderful book and absolutely a thriller in every ways. How does this format that you use, the telling of this story, which in my opinion and in others, it really is this thriller, how does it enhance maybe the understanding, the excitement that went into the scientific process, so that us non-scientists, particularly those in my audience, the 60-plus age demographic, how can we get our head around that? Because I just think it is just another fascinating element.
Yeah, it's because what I'm, if you want, I'm not saying the science in the book like that. I'm not explaining the science per se. Mm-hmm. I'm more using the personal history of the scientists, their drama, their difficulties, their stubbornness in some case to pursue the work, even if they were demoted or they didn't get the grants that they were after, or they have the skepticism of pharma company in many occasions that basically kill their work at the time, and etc. It happens 3 times that pharma company have the opportunity to develop it, and they renounce it. They just kill their project at the time.
Well, you mentioned Merck as one of those.
Merck at the beginning in the beginning of the 90s, Merck. They knew, and they try a little bit, but DNA. They have a DNA technology competing at the time, and because DNA is more stable, because DNA was much more popular, they decided to follow through. They were not successful in this case, but basically they have the 2 platforms on the table, and they hoped to develop DNA instead of mRNA. And should they have make a different choice, maybe today Merck would be the king of the mRNA space, and not Moderna and BioNTech, and so that's things happen, but it's quite dramatic. And naturally, when I'm really telling the story of those people, their difficulty, because when you do that, you can sort of thread the scientific information into those personal information. So why was it an obstacle? And then you have to go back a little bit to science, 1 or 2 paragraphs where you explain a little bit of the biology, and then you go back to the personal history of the person, how he has overcome this difficulty, and what was the next one, and etc. And that's how you sort of thread the scientific information, slowly infuse it for the readers to have the time to grasp it and understand how all of that is built. But then, we all relate to people. Yeah. If I have done a scientific presentation of all of that, people would be like, "Oh my God, it's impossible to grasp." And by writing the story of scientists, it's quite the contrary, because we all have our difficulty in our job. We know that when our boss do not believe in our project, it could be painful. People are losing, careers and all kind of things happen. So I think by relating this personal story with the underlying science, if you want, it sort of explains the science quite easily. It makes it easy to grasp with.
Yeah, and you write so well about this idea of skepticism and mockery from peers in the science community. What did you learn about some of that emotional toll, the disappointment that came with this innovation on some of these participants in the research? Because there were some real amazing stories of people and how they overcame some of that.
Mm-hmm. Well, if you take the example of two of the researchers that have been key in all of that, Katalin Karikó and Drew Weissman at University of Pennsylvania.
They're really the heroes.
Yeah, now they have a Nobel Prize for their contribution in all of that, because they make a key discoveries that unlocked, particularly for the vaccine development, the possibility to make it. And basically, they get, Katalin Karikó started to study the mRNA and started to be very convinced it could be one day a therapeutic or a vaccine already in the beginning of the 80s, and at the time she was in a university or a research center in Hungary, and she has to travel to the U.S. Because she was behind the Iron Turtle, and she has no access to certain funding, to certain technology, and etc. So she came to the U.S. with taking every week, and she basically she sell her car with her husband in Hungary, and they get $1,000 for it, and then they move to the U.S. with a starting position, not a professorship. It was really to become as a researcher, and she has been sticking to it for more than 30 years, for almost 40 years, and it's a stubbornness. And you can say the same with many of these researchers that allows them to, at the end, get, first a medical product that can be used and that is important, and secondly, the recognition of a Nobel Prize, which is in science the best you can get. But it takes 40 years. And it's not easy. When Katalin Karikó in 1995, she was demoted of a professorship because she was not in a position to get the grants from research grants, and so she got demoted. At the same time, she was diagnosed with a tumor in her breast. I mean, she has quite heroic life, and I take Kathy, who is an extraordinary character, but many others have had the same type of career, a very hectic career, because pharma and most of their colleagues did not believe it would be possible to do something with messenger RNA.
Amazing book. Again, our guest today is Fabrice Delaye, author of the new book, The Medical Revolution of Messenger RNA, a strong science component, but a thriller. Lots of business aspects. I just feel, Fabrice Delaye, that the book will offer fresh hope for our audience, especially those who are older, and they might be facing some of these kinds of issues themselves in healthcare, but it's a really wonderful story, Fabrice Delaye, and I so appreciate your time.
For your audience, I can add there is a website
please.
From the U.S. government that is called clinicaltrials.gov, and if you go there, and it's like a Google, if you want, of clinical trial. And if you put mRNA and a type of cancer, you will see. Well, if you put messenger RNA as a keyword and you search how many trials there is, last time I looked, there was more than 3,000. And I will say that before COVID, there was maybe 30. So it's a huge leap. Now every biotech and pharma company is developing an RNA program. It has, there's a lot of development, and people can see that the status of this clinical trial is they are hiring people for. So it could be useful to know that there is. They will see the hospitals that are involved and etc. And this clinical trial are recruiting people to test. That's for sure. It's still experimental. It's not proven. But when you have stage 4 type of cancer and etc. Anything that could be done should be done because there's no alternative. So it's when you have exhausted all classical ways, why not turn into experimental and participate in one of these clinical trials that are recruiting patients? It could be. I would do it for myself, and I would do it for my family if I were in that situation. Definitely.
We'll put links so that our audience can find out more about clinicaltrials.gov, as well as information about Fabrice Delaye, his new book titled The Medical Revolution of Messenger RNA, his work in science and technology. The book is just fantastic. Again, lots of wonderful resources, as Fabrice just mentioned. There's a great glossary in the book, a timeline, a bibliography. You can just learn so much. And again, the book is just written in this very real sense of here's what took place during Operation Warp Speed, a time that we developed the COVID vaccine, but so much was behind that. Fabrice Delaye, thank you for your time and for telling this story. And again, I'll just say selfishly, we'd love to have you back. Science is something that we are all interested in and we need to know more about. So as you do more work in this area, please come back.
Thank you very much. It was a pleasure.
My thanks to GoldCo, Protect Your Retirement Savings, and CrunchLabs, Think Like an Engineer, for sponsoring today's show. Please support our sponsors as they in turn support the show. My thanks to Fabrice Delaye for discussing his riveting new book, The Medical Revolution of Messenger RNA. My thanks to you, my wonderful Not Old Better Show audience on radio and podcast. Please be well, be safe, and let's talk about better. The Not Old Better Show on radio and podcast. Thanks, everybody. We will see you next week.
Thanks for joining us this week on the Not Old Better Show. To find out more about all of today's stories or to view our extensive back catalog of previous shows, simply visit notold-better.com. Join us again next time as we deep dive into some of the most fascinating real-life stories from across the world, all focused on this wonderful experience of getting better, not just older. Let's talk about better. The Not Old Better Show.
Hi, one final thing. Today's show was edited for length. To hear the full interview, please check out our website for this episode and all episodes at notold-better.com, or subscribe to the podcast on Apple Podcasts, and be sure to check out your local radio stations to find out more about the Not Old Better Show on podcast and radio. You can find us all over social media. Our Twitter feed is Not Old Better, and we're on Instagram at Not Old Better too. The Not Old Better Show is a production of NOBS Studios. I'm Paul Vogelzang, and I hope you'll join me again next time to talk about better. The Not Old Better Show. Thanks, everybody. We'll see you next week.